Okay, now let's find the following limit of this function x over ln of x as x goes to 0 plus. Okay, so the aim of this video is to learn about L'Hopital's rule and when can we use it and when we can't. Okay, now it's the good idea is to see where this function is defined. First thing is that the log is defined when x is bigger than 0, and to avoid dividing by 0, we need to have the log different from 0. Okay, with these two conditions, okay, we can see here graphically, okay, so the log is 0 when x is 1, and with this condition we have x is bigger than 1 and x different from 1. Therefore, we have the domain in this case is 0, 1 union 1 plus infinity. So this is our domain here, okay? So that's what we're gonna have. So the domain here is, let me write it one more time. Domain of f is 0, 1 union 1 plus infinity, okay? So now we can start evaluating our limit, okay? So the first thing that we need to do is we can just plug this result. So x goes to 0 plus, that means we have 0 plus over when we get to the log from the right by 0, we're gonna have minus infinity. Okay, now can we conclude? Yes, we can. So we're dividing a small number by a big negative number. What can be expected? What can be expected? The limit. What limit can we expect in this case? It's 0. Okay. The mistake that we make is that we arrive to this result here and we say, oh, now let's use L'Hopital's rule. Okay. The funny thing here is that we don't have the conditions to use L'Hopital's rule. Okay, because to use L'Hopital's rule, we need to have, let's say we want to compute this limit, not this one, f of x over g of x as x goes to some a. We need to have these limits, we need to have this condition, either f of 0 over 0 or infinity over infinity. Okay, and when we compute the derivatives, we need to have g prime of x is different from 0. Okay, so we don't have this form here, and that's why we can jump and use L'Hopital's rule. But if we do and use L'Hopital's rule, let's see what we can get. So let's see our function here, the limit of x over ln of x, okay, as x goes to 0 plus. So let's say we didn't pay attention to these conditions, and let's use the L'Hopital's rule. Now we're going to compute the derivative of this one. It's going to be 1, and the derivative of this one is going to be 1 over x as x goes to 0 plus. We're going to get the limit of x as x goes to 0 plus, and that's 0. So even without worrying about the premises of the L'Hopital's rule, we arrive at the same result. And this is very crazy. Okay, can you explain why it works here? Okay, so there is an explanation for this. Okay, another thing is that sometimes L'Hopital's rule works when we are trying to get the limit on some value but not the other for the same function. For instance, if we consider the following function g of x as x over x plus sine of x. Okay, now we're trying to evaluate this limit. So we're trying to get to 0, and we have these two functions. This is f and this is, let's call this is f, this is h. So we have the limit of this one when x goes to 0, it's going to be 0. So it's limit of x over x plus sine of x. So when we evaluate, so we're going to get 0 over 0. Yes? So we can use L'Hopital's rule in this case. So 0 over 0. And when you use the L'Hopital's rule, we're going to have the limit of 1. We use the derivative 1 plus cosine of x as x goes to 0. When we evaluate, we're going to have 1/2. And that's the true limit. Okay? We can get this limit without using L'Hopital's rule. Okay? But if we try to use L'Hopital's rule works, but we can compute this one without using L'Hopital's rule. But let's see what happens when we're trying to compute the limit when x goes to infinity. If we do the same thing, okay, so we have 1 over 1 plus sine of x, okay, and you can compute this limit, okay, and even without getting here, we don't have the conditions, okay, because when we are trying to use L'Hopital's rule, so this is infinity, and what's this one here? Okay, this function keeps bouncing up and down between some values. It doesn't go uniformly to some other. Let's say the limit, some specific value. So we need to pay attention to the conditions. You need to have these forms: 0 over 0, infinity over infinity, minus infinity over minus infinity. Okay, so that's the kind of situation where we can apply L'Hopital's rule. We need to know the conditions before applying the rule. Okay, and I think this is all we need for now.